All right, hello everyone. Welcome to my talk. We're going to cover IntelliJ plugins and how you can build a simple one to streamline your workflow. So first we'll start. My name is not Thomas, it's Tom. I work for Capital One as one of our Android platform engineering leads. I've been doing Android development since 2010 when Eclipse and the ADT plugin was our main driver. It was back when I think Android Cupcake was released, right around that time, either Cupcake or Donut. So how many of you have seen this happen before? You hire a bunch of engineers, your output stays the same, but now you have more engineers. So I believe in a streamless and intuitive developer experience is a critical driver for success. For Android engineers, superior DevX translates into higher productivity, improved application quality, greater capacity for innovation, and happier engineers. In my opinion, DevX is not prioritized enough. Areas like onboarding, context switching, automatable actions, and support need more attention. Onboarding is usually broken down into a few steps, with some companies going so far as to measure the time to first commit. Context switching between code and being outside of the code base has a variable hit to engineering throughput. CLI interactions with build tools like Gradle are one of the primary ways we all validate changes. However, in large code bases, there could be a potential for better abstractions of some of these tasks. And our support of our larger Android community breaks down into business as usual or run the engine tasks, such as third-party library upgrades, language support, bugs, production issues, documentation, and direct and indirect forms of communication. So if you're like me, a little bit down about it, so what can you do? Why not build an IDE plugin? The IntelliJ Platform SDK provides a platform for building IDEs, such as Android Studio from Google. It's used to power JetBrains products and is an open source. Plugins are primarily written using Java and Kotlin, with the UI written primarily in Swing or Compose, and then there's a Gradle sublayer. There are many existing plugins that some of you may already be familiar with, like Android Design Tools, the Android IDE plugin, and the plugin DevKit. Plugins can range in complexity from simple menu items to supporting entire languages, and in some cases, implementing an actual IntelliJ plugin may be overkill. So some alternatives exist, which are worth naming. You have structural search and replace, IDE scripting and console, and the Flora plugin. And I'm open to going into those in more detail later. So I am far from any authority or expert on IDE plugins, so I would recommend learning more about them from the best. Even most recently, JetBrains held their first plugin developer conference back in November of 2024 with nearly 7 hours, I think it was like 6 hours and 57 minutes of content. And there's no way I'm besting that today. You're not all going to be here until like 9 o'clock. So what are the goals when creating an IDE plugin? We want to improve DevX, provide the ability to personalize dev environments, standardize, and more importantly, codify best practices, decrease context switching, provide shorter feedback loops, and streamline support and troubleshooting. To provide a teaching aid that complements this presentation, I created an open source project called SimpleJ. I want to emphasize that it's meant as a teaching tool to inspire ideas for better DevX and provide code examples and recipes. The project and its IDE plugin are not meant to be used as a literal utility or something that should be or will snowball into a larger DevX IDE plugin. And do you like my logo? Gemini helped me out with that, so you can blame it for the extreme accuracy. It is available on the marketplace. If you have your IDE open right now, please don't do it right now, but if you had it open, you could search the marketplace for it, install it, and begin using it. Please note, this project was not created using the IntelliJ plugin template. I sought to start the project out from scratch, only adding what I needed when I needed it. And then please also note, the project is far from perfect, so please go easy. And as a matter of fact, I was fixing some edge cases last night, and unfortunately, I'm unable to push a new version because my private signing keys, my upload token, are on another laptop. I brought 2 laptops here, and the third laptop is the one with private keys. So go figure. So SimpleJ consumes a JSON file that informs various actions, like new module templates, browser overlay mappings, and workspace validation checks. More on those in a second. This file is one way to customize the IDE plugin that offered in a shareable file that can be pushed into your codebase. The plugin offers settings that are both populated by the config.json file, as well as offers users the ability to customize their instance of the IDE plugin through settings. Where the JSON file is a global configuration, the ability to customize the plugin and settings is localized to the current machine. When it comes to creating a new module, prior to IntelliJ, engineers would utilize IntelliJ or Android Studio's new module templates, fill in the gaps for additional metadata like code owners, update the prefab files for project-specific capabilities such as convention plugins, DSL usage in the build file, feature architecture and scaffolding, and more. And then delete any unnecessary prefab files, and finally kick off a Gradle sync or two after making updates to the new module. With IntelliJ, engineers only need to right-click on the directory they wish to add a new module within, click New Module, fill in a few details like the module name, the code owner, GitHub team, or username, and then the template of their choice. IntelliJ will leverage the templates defined within the config.json file, update code owners, settings Gradle KTS, and trigger a Gradle sync. When it comes to module deletion, prior to IntelliJ, engineers would manually delete references to the module from a whole bunch of different locations, such as code owners and the settings file. Default deletion within Android Studio can also be problematic and miss references to modules within build files. So with IntelliJ, engineers only need to right-click on the module they wish to delete, click delete, and then if references to the module are found within other module build files, a conditional dialog will display asking users if they wish to proceed. When it comes to executing Gradle tasks, prior to IntelliJ, engineers would manually navigate to the module or directory they'd like to run Gradle tasks within, or trigger the Gradle tasks via the Gradle task panel within the IDE. If they were using the terminal, there was also the potential for concatenating lengthy Gradle paths together for task execution. And finally, engineers would have to remember arbitrary task options or properties whenever running specific commands. With IntelliJ, engineers only need to right-click on the module, directory, or file within the module they wish to run the task, click the task or task cluster they want to execute, and IntelliJ will find the closest project or module to execute said task within. By default, IntelliJ offers a preloaded task actions, a couple preloaded task actions, which can be toggled on and off through settings. So note, for this one in particular, prior to creating the open and GitHub action, I wasn't aware that it already existed. Within IntelliJ Ultimate at least it does. It's not there for Android Studio, at least with the, I think it was, what is it? The whale one that we have right now. Sorry, I don't remember it. But I happened to stumble upon that, and I think that really has two takeaways. The first one is there are a ton of helpful actions that already exist. Check to see if the one that you're trying to build doesn't before you do it. And then the discoverability of actions could be improved. So even when searching open in GitHub, open or GitHub, when searching for actions within the IDE, none of the results actually returned the action for GitHub. In any case, so prior to IntelliJ, engineers would need to identify a files repository manually, open the browser tab, then manually navigate to the repository, determine which branch they'd like to view within the code, and then manually copy and share that out. With IntelliJ, engineers only need to right-click on any tracked module, directory, or file, click Open in GitHub, which will automatically launch the preferred browser with a new tab for GitHub, or click the Copy GitHub link to just copy the URL for even faster sharing with teammates. When it comes to looking up who owns a tracked file, prior to IntelliJ, engineers would need to search for code owners for parts of the file, which has many pitfalls, as ownership claims within code owners can use wildcard pathing, which makes manual searching fallible. With IntelliJ, engineers only need to right-click on the tracked file of interest, click Look Up Code Owner, which will then prompt a sticky notification with two actions, one for opening code owners to the exact location of the claim, and the other for copying the listed code owners for quick sharing. When it comes to validating workspace environment pointers and installed tooling, prior to IntelliJ, engineers would fix environment issues as they became blockers, which would then open the doors for silent failures and behavior differences. Despite best documentation, it's far too easy to miss workspace configuration steps. All of these things result in a back and forth with our support engineers. With IntelliJ, engineers only need to right-click, click Validate Workspace, which runs 3 main environment inspections, checking for misalignment, misaligned Java versions or home values, misconfigured SSH steps, which installed versions of Android build tools are present, and more. In all, this gives users the ability to self-service and something to discuss with support engineers when they encounter issues. So as a bonus, there's a nifty feature that overlays a browser within the IDE. Shout out Louise from one of our platform teams for not only the idea, but the implementation. The reason this is so helpful is because you can map files or directories to documentation websites. Prior to IntelliJ, engineers would manually find documentation websites, context switch between the browser and the IDE, opening the door for more distractions, and there were no clear preferred doc websites for certain frameworks, projects, or file types. With IntelliJ, engineers honestly just need to know that if they need docs and those files have been mapped properly, then clicking on the globe icon in the lower, left, will open up the doc website in line within their IDE. So how did IntelliJ do when it came to our goals? It improved the developer experience through various actions. It allowed for personal dev environment configuration through settings. It standardized best practices through module creation templates. It decreased context switching with browser overlays. And it provided better troubleshooting and support through workspace validation checks with shareable GitHub links and quick code owner lookups. So how do we build an IDE plugin functionality like what we saw in IntelliJ? So let's cover some of the basics of IDE plugin development, including project setup, project structure, defining actions, prompting for user interaction, writing updates to file, and distribution. Before getting into it, I want to call out that this presentation does not cover updates to the settings or testing. Testing in particular would likely take over about 15 to 20 minutes. It might be a good idea for another lightning talk. Assuming that you're starting from scratch, I would highly recommend creating your plugin using the IntelliJ plugin template, which is extremely easy if you install the plugin dev kit from the IDE plugin marketplace. Creating a new plugin is as easy as file, new project, and then selecting the IDE plugin generator. One gotcha, however, I thought this was rather interesting, is that despite the ability to choose whatever JDK you would like to target, the plugin dev kit requires JDK 21. So just keep that in mind. So once we generate the project, the resulting project structure output will look something like this. As denoted on their README, there's a few callouts worth mentioning. Ensure that you delete all generated code files that were not needed, as well as dependencies that are unused. Qdana, which is a smart code quality platform offered by JetBrains, is best suited for working in teams. It does have some pricing models, and reports are hosted on the Qdana cloud, just as a heads up. And then finally, it does prefab out with Cover. Cover is the Kotlin code coverage tool by JetBrains. It's still in beta, and again, just another heads up. And finally, you may notice that this is a single module setup, which is not great for scaling larger IDE plugins with potentially many contributors. So luckily, through the use of two Gradle plugins offered by JetBrains, we can modularize any IDE plugin project. The host project must apply the platform plugin, which we see in the top box. All other submodules that are both IntelliJ aware and consumed by the root project must apply the module plugin, which is the middle box. Dependencies from the host plugin to those submodules look like the code snippet on the bottom. Note that base is added to both the implementation dependency configuration and another called IntelliJ Platform Plugin Module. This guarantees that the submodule content will be merged into the main plugin's jar file. Otherwise, you'd have to write some custom Gradle logic to create an Uber jar output from the host. And I would know because I missed that in the documentation, wrote a whole bunch of custom scripting, and then found out later on that they actually offer this by default. Now, the updated project structure, once we apply those plugins, should look something like this, where we have a highlighted host and a base. The project now contains both of those modules. Shareable extensions would go into base, while host contains logic, actions, and code specific to the plugin that it outputs. So within the plugin, now we set up, with the plugin now set up, let's discuss the plugin XML. This file reminds me a lot of the Android manifest file as it creates a blueprint for capabilities and functionality the IDE offers. For simple plugins, some key elements include ID, name, version, description, and change notes, all of which being rather obvious by their named values. Depends specifies a dependency on another plugin or module of an IntelliJ platform-based product. For instance, you could add a dependency on the Android plugin. Extensions define plugin extensions, such as notification groups, application services, and configurations for stuff like plugin settings. And then finally, actions, which define plugin actions, such as the AN actions. This is the most basic entry point to trigger plugin logic. So what we're going to do now is we're going to define two actions. The first action here is going to be for creating a new module. And the second action that you see down at the bottom is for running the Gradle check task. One thing to highlight is that the top action is not contained within a group, whereas the bottom action is. Actions can be both group lists and within a group. Putting actions within a group allows you to cluster similar functionality, like running the check task, static code analysis tasks, as an example. So there's further conditional display logic that can be added within the AN action as you see fit. For simplicity's sake, though, all of these actions are actually grouped within they're actually clustered within a larger group called my group. That's not seen in this code snippet here because it would have been a little bit too verbose. So right-clicking a project, sorry, give me 1 second. This slide deck is actually like V1 of V5, and I'm realizing that right now. So I have like a bunch of slides that are going to be a little bit. All right, sorry about that. I think some of my windows may have gotten a little off. So we did cover the actions portion here. I'm going to speed us up a little bit. So let's take a look at the new module actions code. The new module action extends from AN action. The IntelliJ platform calls methods registered from AN actions when the user interacts with the menu or the toolbar. There are three main functions of an AN action. Get action update thread, which determines the thread on which the update should be called. Update, which can change the presentation of the action, changing its visibility, icons, the actual text. And action performed, which performs the action while executing on the UI thread. We can quickly visualize our new actions by launching the development IDE instance. This is accomplished by executing the run IDE Gradle task. Worth calling out, the run IDE Gradle task has options that allow you to specify how the development IDE behaves and loads. You can specify things like a default project so that when the development IDE launches, you don't have to sit there and sift through your other Git projects. It launches directly into what you want to test against. as well as JVM options like more memory and whatnot. Additionally, the development IDE is debuggable through the use of the --debug-jvm task option and an accompanying remote JVM debug run configuration. So as we can see, when I right-click on the root directory, I'm presented with my group with the two actions that we added. A couple things to point out. Notice that the location and grouping of the actions as a direct result of using groups, where one is not contained and the other one is within the run ... group, and the icon sugar to the left of each action. Within the new module actions action performed function, we're going to validate that we have non-null project and project file pointers. Something worth calling out is that the event.project will typically always return the root project present in the workspace, not the project closest to the event or the file that triggered the action. Now let's prompt a dialog for the user to fill out. We'll return to the create new action function in a second. So in this example, new module dialog extends IntelliJ's dialog wrapper while setting a couple fields. The dialog's title is set to create new module. We're informing the IDE that the dialog should both be showing an OK and cancel button, as well as have a callback to the dialog when the user clicks OK, and ensuring the user cannot resize the window. On the right, we're building out the dialog center panel. This is the panel that the user will predominantly see. We're using Kotlin's UI DSL version 2.0. The DSL defines a row for the module name with accompanying input field, a row for the GitHub team or name with an accompanying input field, and a dynamically populated series of radio buttons informed by SimpleJ's config.json. And this is what it ends up looking like. You can see that the top row has focus, we have an input field for module name, and so on. However, if we wanted to use Compose Desktop instead of Kotlin UI DSL, what would that entail? You'd first need to add a mix of the above to your dependencies TOML file, as well as place dependencies on those libraries within the project's build file, whichever module within the project you have the need to use Compose Desktop. And this is the same exact setup as the original new module dialog, except the center panel is now using Compose Desktop. So please ignore my use of Compose if it looks pretty awful, because it is. I blame Gemini Pro, but if it looks really good, that was definitely me. And then you can kind of see Gemini, again, totally screwed this up, but I'll be the first to point out that dialog here needs a little TLC. The theming is not right. But the point still stands. Compose Desktop is an option when building out an array of plugin IDE UI. So once the user has completely filled out the dialog and clicked the OK button, we need to create the new module and its files. The way that you would do this with an IDE plugin is by using the write command action, which throws the file I/O into a background thread and tracks the file I/O performed. This matters as it gives the user the ability to easily undo the module creation and any other updates to accompanying files. Some things worth calling out. When interacting with files, try to favor the IntelliJ Platform SDK virtual files over Java I/O file, as virtual files are monitored by the IDE's VFS. File updates must be in the background, and file reads do not require virtual files or background threading. However, virtual files are still preferred. For distribution, there are three primary ways to distribute. We have the JetBrains marketplace, wherein the first upload is always manual. From then on out, you'll be using Gradle tasks with generated tokens and signing keys. One bit of fun is that you can specify any name for your release channel. It's open season, which is really interesting. You could define a release channel of like Tom or SimpleJ, but that would require informing your customers of this release channel so that they can add it to their IDE to search for your plugin. Some cons are that this is globally public, regardless of the release channel name, which means if you're building a plugin private to your company, it's not something that you want to be sharing, this is likely not an option. You have custom plugin repos, in which you'll create and maintain and update plugins XML file hosted on some repository. Luckily, there's a Gradle plugin to automate the upload of the plugin zip, as well as the creation of the update plugins XML file. Because you own the hosted repository, it can be as open or as walled garden as you would like it to be. Just be sure to let your consumers know the endpoints that they can add it to their IDE. And then finally, we have installation from disk. The title pretty much says it all here. Once you have the zip or jar, you can install it from disk. The serious drawback of this is the manual reinstalling of the artifact when it has changes. For large audiences, this requires broadcasting the update. However, there are ways to script around this, and the disk updates can be automatically applied if you put enough effort into it. And then finally, again, it's worth calling out or worth mentioning that plugins can also be installed via CLI. So a pro tip here is you can configure your project to require plugins that provide support for certain technologies or frameworks. The IDE will notify the user of the project if they forgot to install the plugin, or someone on your team is not aware about the dependency as they work on the project. This can be helpful for companies with high engineering headcount and/or diverse levels of experience. So some final thoughts while putting together this presentation and IntelliJ as a project. In terms of writing the code, JetBrains has amassed an impressive amount of documentation, which is definitely helpful during initial project setup. Once creating actions, extensions, and services, it became difficult to find maintained code samples. There are a lot of do-a-thing managers, some with some moderate overlap. It's not clear which ones to use and when. Swing still being the primary way of building out UI is a little odd, but I get it. The IDE's been around for longer than Jetpack Compose. Support is growing there. Swing form editors being behind a paywall hinders plugin creation. If you're looking to deal with a form editor or a preview panel for an XML Swing form, it's something you have to pay for. The Kotlin UI DSL is nice-ish, but it's unclear exactly how to set up your panels, and the code samples for it are not straightforward. In terms of using Compose Desktop, Joule, the theme built by Jetpack, or the theme built by JetBrains for Compose Desktop, isn't stable yet, and trying to use it while on an older version of Kotlin or Compose proves problematic. The repo is archived actually as of April 2025, as it's moved into the IntelliJ platform, but hasn't yet released a new version or outlined clear integration or compatibility just yet. Kotlin UI DSLs seem much less verbose, as we saw with the code snippets for the dialogue, and you get a full theming support for free. However, there is no previewing of the UI, and the round trip of validations via the development environment IDE is slow. In my opinion, favor Compose Desktop for UI creation sometimes. You can do everything you can do. Everything you can do with Swing with Compose Desktop, but getting the theming and primitives right is a pain with Compose Desktop. And unfortunately, unless you can get your Compose panels just right, they do stick out. If that doesn't matter, then by all means, go with Compose Desktop. And adding the Compose Desktop dependency actually bloated IntelliJ's plugin binary by roughly 94%. Without Compose Desktop, IntelliJ had a footprint of 2.5 megabytes. Simply by adding the Compose Desktop dependencies, it jumped to 39.8. IntelliJ's recommendation is to try and keep the binary sizes of plugins low. So take that into consideration before adding Compose to your plugin. If you're only going to use it on one panel, it's really not worth that hit. Previewing your composables also comes with some options. You can leverage an Android library solely for previewing composables. This is the first option on the left, and it's the one that I chose to go with for IntelliJ. When not using Android Studio, be sure to install the Android Design Tools, and Jetpack Compose IDE plugins. All of these essentially come pre-bundled with Android Studio, and the benefit of this approach is an automatic re-rendering upon code changes. Or you can stick with the more traditional Compose Desktop setup by installing the Compose Multi-Platform IDE, but that requires you to manually click the Compose Preview gutter icon. It also does some interesting things to the package tree and the project panel. Ensure that that's not the only two things. So on the left, we see the automatic preview rendering in real time as code changes are made to the composable. On the right, we see the Kotlin Multi-Platform IDE plugin, which requires tapping the multi-platform gutter icon for re-rendering to occur. This takes your hands off the keyboard. It does introduce some delay. While the GIFs are likely out of sync, I was hoping they would start around the same time. If you caught it when they were in sync, the one on the left started before the one on the right. The one on the right, so Kotlin Multi-Platform started before the one on the left and was still slower to render without an automatic reload. Some additional ideas that I had while working on IntelliJ include pulling machine information that could be shared with coworkers. This is something that you can actually get from the IDE itself. If you click on, I believe it's like preferences or about, and then copy, You get some machine information along with the IDE, like its version and distribution. But in my opinion, that's not enough. Another idea here, automatic fixing of broken or misconfigured environment variables. It's often not just enough to tell someone they've misconfigured their SSH keys. It would be nice to fix it automatically. Some complementary setup functionality, such as the downloading of packages like build tools. That's something we touched upon in the Tech Lead series earlier today. Pulling IDE data analytics on engineering behaviors would be pretty helpful in understanding the time spent doing certain tasks. Could be that a user spends a bunch of time in a task or a bunch of time in an IDE action because the action is misconfigured or because it's a very helpful action. And then finally, creating a feedback mechanism for engineers to use regarding certain actions, both from plugins that you own and plugins that you don't. With that being said, thank you all for coming to my talk today. As I previously mentioned, IntelliJ is an open source project on GitHub and available in the plugin marketplace.